This question is actually an exponentials question because we've got some value and we're timesing it by 1.03 to the power of something, and that is the thing that's changing. T is the exponent and it leads to a particular kind of graph, which I'll talk about in a bit. It's not essential to this question. So sometimes you do get asked about it though. Write down the value of the house on the 1st of January 2010. That's actually when T is equal to 0. So we could use our calculator for this if we wanted to, but I'm going to do it without. It's going to be 165,000 times 1.03 to the 0. This in fact is equal to 1, and I can just ignore it. And actually it turns out for this sort of equation, the starting value will be the constant in front of it. So it's just 165,000. I think this is a good point to talk about the equation. This will be my 165,000, and what happens then is I have an increase every year and times by 1.03, and what we get is an exponential. So it just goes off to infinity, and it goes off to infinity like really quickly. So when somebody talks about an exponential, they tend to mean that it's growing very rapidly. Actually, it doesn't have to be growing that rapidly. This is not growing particularly rapidly, but it will over time get bigger and bigger basically, and it'll go to infinity faster than most other functions. All right, next part, write down the annual percentage increase in the value of the house. This comes down to looking at the multiplier. What we're multiplying by every time is 1.03, and that's actually equal to 103%. They're the same thing. So what does that mean? That means if we have 100%, I'm adding 3% on. I've got a 3% increase. And that's my answer. Okay, finally, show the value of the house is over 200,000 on the 1st of January 2017. That's 7 years later when T is equal to 7. So I'm going to find out H. This time it's going to equal 165,000 multiplied by 1.03 to the 7. And I get 202,929. Which is indeed greater than 200,000.